Now we're going to look at a problem that involves air travel. The distance between Atlanta Hartsfield Airport and Narita Airport in Tokyo, Japan is 6,876 miles. A Boeing 747 is estimated to consume around 5 gallons per mile on a long-haul flight. The emission coefficient, or the emission factor, for jet fuel is 9,644 grams of carbon dioxide per gallon. What is the carbon footprint for this trip? The first step to solving this problem will be to determine how many gallons of jet fuel are consumed on the trip. We know that the flight is 6,876 miles, and we know that a Boeing 747 consumes about 5 gallons per mile. So this is just a simple multiplication problem. So 6,876 miles per trip multiplied by 5 gallons per mile equals 34,380 gallons per trip. So a trip from Atlanta International Airport to Tokyo, Japan, a 747 will consume approximately 34,000 gallons of jet fuel. The next step is to simply multiply the consumption by our emission factor, which is in grams of carbon dioxide per gallon. So let's take the 34,380 gallons per trip and multiply that by 9,644 grams of CO2 per gallon, which will give us another relatively large number, 331,560,720 grams of CO2 per trip. And now all we need to do is convert to metric tons. A metric ton has 1 million grams. A kilogram has 1,000 grams. There are 1,000 kilograms in a metric ton. Therefore, a ton has 1,000 grams. So all we need to do is to divide this number, 331,560,720 grams of CO2 per trip, and divide that by 1 million, which is the number of grams in a metric ton, and that will give us 331.56 metric tons of carbon dioxide per trip. And that is the answer, which is answer C. Next, we're going to look at a problem involving a landfill. This is a relatively easy problem again, but it incorporates something that we haven't addressed yet, and it's something that we will be using in some of the next problems that can complicate matters if you're not prepared. A 66-acre lined cell landfill contains 2.4 million tons of waste. At its current level, the landfill emits 2,000 metric tons of carbon dioxide and 2,000 metric tons of methane each year, with traces of other compounds as well. Looking only at the methane and CO2 emissions, what are the total emissions per year in terms of CO2 equivalents? In this example, assume methane has a global warming potential of 21. Now, if we were in the United Kingdom, then we may assume that methane has a global warming potential of 23. In this case, we're going to use the EPA's reference data, which is 21. So the first step is simply we have 2,000 metric tons of carbon dioxide emissions. So 2,000 metric tons of CO2 per year. And we're going to multiply that by the global warming potential for carbon dioxide, which is 1. And that's going to give us 2,000 metric tons of CO2 equivalent per year. Now we're going to do the same thing for methane. We have 2,000 metric tons of CH4 or methane per year. We're going to multiply that by its global warming potential, which is 21. And that's going to give us 42,000 metric tons of CO2 equivalent per year. And the final step will be simply to add these two together. We have 2,000 plus 42,000, which gives us a total of 44,000 metric tons of CO2 equivalents per year. And that is the final answer.